months ago in September this year in Monaco. More than 1,000, oh, there's something happening. More than 1,000 experts did contribute to the development of this special report in different ways. We had 104 selected authors, coordinating lead authors and lead authors. They built the core writing team. This core writing team was supported by more than 200 additional contributing authors. And on top of that, more than 800 expert reviewers did help to shape and improve this report by providing more than 30,000 comments during 3 review rounds. Oh yeah, okay. Yeah, that's good. Here we go. Okay. This is the cover of the special report, and the cover reflects the different systems that are considered in the report. So the systems considered range from the polar regions to the tropics, and from the top of the high mountains to the bottom of the deep sea. And some of the key findings related to these systems are now presented today here by some of our authors. So first, we're going to get some insights in oceanographic changes by Carina von Schuckmann, followed by our changing polar regions presented by Martin Sommerkorn. After that, Elizabeth Holland is going to give us some insights into the small island perspective. And Jean-Pierre Gattuso, in the end, is going to move into the solution space and is going to present ocean-based mitigation and adaptation. After these presentations, our IPCC Vice Chair, Co Barrett, was so kind to agree to provide us with an expert commentary from her perspective. But before we start going into the presentations, I have the honor to present you here for the first time our new SROCC video, which is hopefully going to work. This video has been finished last night, so you are the first to see it. And I hope you like it.
Ocean and the frozen parts of our planet, our cryosphere, may seem far away, but they shape the way we live and help to sustain life everywhere, providing food and water and are key components of the global climate system. The ability of the world's ocean and cryosphere to provide these services is diminishing, as they have been taking the heat for climate change for decades. From polar regions to the highest mountains, and all the way down to the depths of the ocean, we are seeing the impact of climate change on plants and wildlife, landscapes and oceans, as well as on our health and well-being, our culture and identity, our industries, our energy and transport systems, our cities and infrastructure. In our Arctic region, sea ice is decreasing. Ground that has been frozen for thousands of years, called permafrost, is also warming and thawing, causing buildings and infrastructure to collapse and coastlines to change or erode. Widespread permafrost thaw is expected by the turn of the century.
Permafrost is very vulnerable to warming. Also, contained within this permafrost is a vast amount of carbon. The amount of carbon that's stored in permafrost is basically about double of that contained in the atmosphere at present.
In high mountain regions, the melting of glaciers and the thawing of ice and permafrost are increasing hazards such as landslides, avalanches, rockfalls and floods, while also affecting cultural heritage, recreational activities and tourism. As high mountain glaciers retreat, they are affecting the availability and quality of water. not only for high mountain communities, but for agriculture, hydropower, and cities downstream that are home to millions of people.
When glaciers melt, they release water that is stored in the glacier. And that means first, when the melt occurs, there's more water because of the melt. But as the glaciers retreat and shrink, there's actually less water available for agriculture, for hydropower, and so on.
About 1/3 of the Himalayan glaciers, for example, will be melting by end of the century.
Further significant changes can be seen in our vast ocean. Melting glaciers and ice sheets, together with the expansion of a warmer ocean, are causing sea levels to rise. And the speed at which sea level is rising is accelerating, with our global sea level rising twice as fast as it did during the 20th century. In low-lying coastal megacities and on small islands, sea level rise is increasing the frequency of extreme sea level events during high tides and intense storms. On small islands, the impact of sea level rise can be severe.
Well, you have, first of all, some erosion and the loss of land, and those small islands, they do not have that much land to start with. You also have the problem of the contamination of the land with salt, and on the water that is stored under that land. If it is contaminated by salt, you cannot drink it anymore. And if your soil is contaminated by salt, you cannot grow the crops and the vegetables, so you have food supply and health issues. Those are the major challenges.
Over the past few decades, our ocean has absorbed more than 90% of the excess heat in the climate system and taken up between 20 and 30% of human-induced carbon dioxide emissions. Ocean warming has reduced the supply of oxygen and nutrients to marine life, while increasing CO2 levels cause ocean acidification.
This decreases the ability of calcifying organisms to build shells and skeletons.
These changes have affected the distribution and abundance of marine life in coastal areas and in the open ocean. Across the world, we are already starting to respond and adapt to changes in our ocean and cryosphere.
One of the most immediate things that we can do is to reduce other non-climatic impacts on marine ecosystems and the oceans. Overfishing, habitat destructions, pollution can exacerbate the impacts of climate change.
Climate change are very local specific, and communities across the world are using their own knowledge to adapt to climate change.
But adapting to a changing environment is not enough. To address unprecedented and long-term changes in the ocean and cryosphere and safeguard our livelihoods and communities, we need to protect and restore our ecosystems and carefully manage our use of natural resources. We can do this by engaging with local communities and indigenous peoples and improving governance systems, while at the same time taking urgent steps to reduce greenhouse gas emissions.
There may already in some places changes that we may not be adapt to, because these changes are irreversible.
But we still have a chance to make a difference.
The way these systems operate, there's only one way to protect them and to minimize changes, limit the changes that are developing, and that is by steep reductions in emissions and reaching net zero emissions by mid-century.
We're seeing the ocean and the cryosphere changing already, and how quickly they continue to change will depend on how rapidly we take action to reduce greenhouse gas emissions.
I'm optimistic because I've seen the way that these issues are starting to gain more and more traction. I think it's really important to keep the faces of folks who are vulnerable to these changes in mind as we consider actions that we all can take for the future.
Working together, we can protect our ocean and cryosphere and secure our future.
Excellent, thanks a lot. I think that was a good start into this session, and I would like to ask Carina von Schuckmann now to start with the presentation. There you are, sorry, I didn't see you. Carina is an oceanographer specialized in ocean climate monitoring. She is lead author of Chapter 1 of the special report, and also a lead author of Chapter 2 of the Working Group 1 main report, which is currently prepared. She is living and working at Mercator Ocean International in Toulouse, France, from where she's also chairing the activities of the Copernicus Marine Service Ocean State report. Right?
Okay. So I will deliver some insights of the outcomes of this special report on the ocean cryosphere and the changing climate. Specific focus on the oceanographic changes, on ocean warming, ocean sea level rise, ocean acidification, and ocean deoxygenation. I would like to start with a view on how the Earth system functions. The Earth system is an interconnected system which is aiming to rebalance to an equilibrium state in case there is any perturbation. So this Earth system regulation is primarily driven by the flow of heat, energy in the form of heat, fresh water, and biogeochemical substances like carbon between the different components of the Earth system. So the ocean and the cryosphere, but also the atmosphere and the land. Facing climate change, the ocean plays a particular role within this Earth system regulation. That is, it takes up the majority of heat accumulated in the Earth system and large amounts of carbon. And this service of climate regulation has some symptoms, and those symptoms include ocean warming, ocean acidification, sea level rise, and ocean deoxygenation, amongst others. So ocean warming, due to the emission of heat-trapping gases resulting from human activities, the global ocean has warmed as it has taken up more than 90% of the excess heat in the climate system, making climate change irreversible. So this is shown here, the figure on combining the information from historical observations, modeled information going up for scenarios under high increased gas scenarios and low greenhouse gas emissions. And the main methods for ocean warming from SROCC is ocean warming is continued unabated, and since the last 3 decades the rate of ocean warming has increased, and around half of the total heat gain in the global ocean has occurred in the Southern Ocean in the last decade. The ocean will continue to warm throughout the 21st century. By 2100, the ocean will take up 2 to 4 times more heat if global warming is limited to 2 degrees, and up to 5 to 7 times at higher emissions. Ocean warming is also one of the major drivers of sea level rise by the expansion of thermal expansion of seawater through the ocean warming effect. Another, which is the most dominant, I defend most dominant contributor, is the melt of Antarctic ice sheet mass and glaciers and Greenland ice sheet mass loss. Sea level rise during the 21st century that has shown the result that the global mean sea level rose by about 15 centimeters and is currently rising more than twice as fast. The sea level rise will further accelerate, reaching up to 1.1 meter in 2100 if emissions are not sharply reduced. And there is no scenario that stops sea level rise this century. We have the choice between 1 meter and up to several meters of sea level rise by 2300. Ocean acidification is another major consequence due to the service of the ocean regulating the perturbation from anthropogenic emissions in the climate system. So the ocean is taking up 20 to 30% of the global emissions from human activities, estimated here or measured for the past 3 decades. And the increase in anthropogenic CO2 occurs throughout the upper 1,000 meter depths, and the penetration of this is here for the Atlantic Ocean, the Pacific Ocean, and the Indian Ocean, showing that there are different penetration depths depending on ocean circulation and also on biochemical mechanisms. And this is reflecting differences in the efficiency of taking up carbon within the ocean, and with the tropic CO2 is transported from the surface to the deep layers of the ocean. The results on the assessment on ocean acidification has shown that as a consequence of anthropogenic carbon uptake, the ocean has undergone increasing surface acidification, and continued carbon uptake by the ocean by 2100 is virtually certain to exacerbate ocean acidification. Ocean deoxygenation, so the surface ocean warming is making with the surface less dense relative to deeper parts of the ocean and inhibiting mixing of oxygen, but also of heat and carbon nutrients into the deeper layer of the ocean to exchange with the surface up to the deeper layers. So as a consequence here, specifically for the topic of ocean deoxygenation, the loss of oxygen has occurred from the surface down to 1,000 meter depths and is projected to further decline over the 21st century. So there are specific changes, and my focus for this presentation was on the ocean warming, ocean acidification, ocean deoxygenation, and sea level rise. There unabated strong changes which I did not describe, and the ocean is in transition to new states unprecedented since the pre-industrial era. So it's time to take action. Thank you.
Thank you very much, Karina, for this interesting presentation. The next speaker will be Martin Sommerkorn. Martin is head of conservation of the WWF Arctic program. He is a coordinating lead author of the Polar Regions chapter, chapter 3 of this special report. And he brings science underscoring the role of nature for social ecological resilience to the policy-making table and leads work on the conservation and governance of Arctic ecosystems. The floor is yours.
Thank you, Katja, and thank you for giving me the opportunity to speak here. Yes, as Katja said, I was a coordinating lead author for the Polar Regions chapter, and for that purpose actually stepped back from my day job and concentrated on delivering this chapter. So today my talk about the polar regions really focuses on what that may mean in the context while we're here, COP25. I start with a synopsis of the chapter, of the Polar Regions chapter, and where do I even start to unpack the polar regions? The polar regions are key components of the climate system. They are majorly affecting the climate of the planet. They are affected by themselves, they affect the planet. And just to give you a quick overview, if SROCC wasn't covering enough, i.e. about 85% of this planet's surface, the polar regions cover 2 of our planet's ocean. They cover both of our planet's ice sheets. They cover 70% of the glaciers of this planet. They cover all of the sea ice of this planet, and they cover both the regions that have persistent seasonal snow cover. So that is why the polar regions are so central. And we conclude this chapter by saying that the polar regions are losing ice in all forms, their oceans are changing rapidly, and that these changes have global and regional impacts. We also have to see that the polar regions of the future will appear profoundly different in the future, dependent, though, very much on the degree of warming, which brings us back to why we are actually here. We also constitute in the chapter that choices are available that limit the impacts and the consequences from climate change in the polar regions, that build resilience to the changes, but that their efficacy really have to be enabled in order to let us benefit from these reductions. So what we are here for, really, at COP25 are themes that are put here on the table. And these are not my themes, these are the themes that are discussed in the corridors and the political part of this. It's about ambitions, you see that everywhere. It's about nature. It's about seeing how nature can actually enable responses and help us dealing with a problem. And it's about people, putting people in the center of the actions that are necessary and their well-being in the center of how far we can go. So I'll unpack with having these 3 themes in mind, and I ask you to do the same because we are seeing some of the same graphs again, but we will maybe unfold them slightly differently. So you have seen this before. It's the post and future changes in the ocean and cryosphere with a particular view on the polar regions, Arctic sea ice extent, Arctic snow cover extent, near surface permafrost area on the right, and the contributors to sea level rise, ocean heat content, Greenland ice sheet mass loss, Antarctic ice sheet mass loss, glacier mass loss on the left. And what we see in the report is that we are, for the first time now, seeing the glacier loss overtaking as a contributor to mean sea level rise from the increasing ocean heat content. Why is that so important? Because these are irreversible changes that we are seeing, and they will be contributing to the future sea ice loss stronger in the continuation of this century. And that is particularly true for Antarctic, where we are starting to see irreversible changes coming our way with, at the moment, high agreement but limited evidence whether these changes are actually the onset of irreversible ice sheet mass in the West Antarctic. This will commit us to centuries of sea level rise, and you can see that this is an interesting part that was actually requested by the governments when we came up with a summary for policymakers of this report. We were asked to make clear how this is actually a multi-century commitment in the graphic itself. Sorry. So what that means in terms of the two scenarios that we have on the board here, the RC 2.6, which is roughly equivalent to a Paris Agreement, gives us 2 in 3 chance to stay in line with temperature increase of the Paris Agreement, and a business as usual almost a scenario of RCP 8.5 where we don't have strong policies to constrain greenhouse gases. We urgently have to choose which future we want. The future of sustained changes and their consequences, or one where we can actually stabilize, even at a lower level, some of the key cryosphere elements of the polar regions, such as Arctic sea ice extent in blue and Arctic snow cover extent in the second one on the right. So going to the Arctic for a second and telling you a little bit more about what that means in terms of what these changes may mean in terms of the ocean environment. We have seen sea ice loss of about 13% per decade over the last 50 years. We have seen the Arctic Ocean warming by about 0.5 degree, and these things are mutually affecting each other. So lots of the sea ice warms water, and sea ice loss is warming water and actually affecting further warming. Some of the warming of the Arctic Ocean also comes through increased inflow. But all of this change actually then also feeds back on other cryosphere elements on land. In the future, we will see that, for example, with a, does this have a pointer? No. That with a scenario that is congruent with 1.5 degree of warming, we will see the chance for an Arctic sea ice summer by the end of this century to be about once a century. Whereas we will see already with 2 degrees that likelihood to raise to every 3rd or 10th year. So what we will also see, what we are also seeing is that over the last 40 years, the Arctic and the Antarctic Ocean have been acidifying, and the outlook for that is pretty bleak. Cold water takes up more of the CO2. The Antarctic Ocean, the Southern Polar Ocean, has taken up a disproportionate amount of carbon in the past. And if we look at the RCP 8.5 scenario, we see year-round corrosive conditions for calcium-building organisms by the end of this century, widespread throughout both polar oceans. That is vastly reduced. That's a vastly reduced conditions under a Paris Agreement compatible scenario. So this is what we will be facing. And if we look now into how nature is affected, how human systems are affected, how people are affected, then we can constitute in the Arctic that these changes are not going to be uniform, but we also see in the graphic here indicated by the red, purple and blue boxes, how there are more negative than positive impacts. Some of the economic sectors do benefit from the loss of sea ice, for example, shipping, resource extractions, but these actually are also creating new risks in the future. if they are not properly handled. We see huge differences even regionally inside the Arctic, how conditions pan out. But as a general trend, we are seeing that especially high Arctic and sea ice associated species are losing habitat and affecting also all the cultural values and the services that are linked to that by people. As a consequence, we see that the income, livelihoods, food security, well-being, and the cultural values that are linked to these systems and to these species and to this way of life are deeply and negatively impacted. Turning to land briefly, we actually do see the same thing, if not worse, because the land is changing so fast and radically. Also here, the incomes, livelihood, and all the ecosystem services that stem from the land are deeply and negatively impacted. For example, by a projected loss of the tundra region by 24 to 52% already by 2050 through the encroachments of trees and shrubs. We are also seeing that the whole landscape is changing because of the thawing of permafrost, and that affects how water flows through the landscape. We have about 20% of the Arctic permafrost being ice-rich, so when that thaws, it causes subsidence of the land, which can create new lakes, slumps, but also lead to drying of some areas. All that puts infrastructure at risk. It is forecast that about 70% of the infrastructure that is currently in the Arctic is situated on surfaces that are due to thaw by 2050. So these are changes that are going to affect everybody who is working and living in the Arctic, and will also affect how we can benefit from these ecosystems. One particular thing that we benefit from is that there is a lot of carbon actually locked away in permafrost. It was mentioned in the presentation. We are due to lose about 25% of the permafrost area in the Arctic under even a low emission scenario, but under a high emission scenario, about 3/4 of that permafrost will be lost. And under that high scenario, we are thinking that this will actually produce a cumulative release of tens to hundreds of gigatons of carbon to the atmosphere in this century. I want to put this into context. Over the last decade, humans have emitted about approximately 11 gigatons per year. So we are adding here at least one, if not tenfold, the amount of anthropogenic emissions during this century, when we are actually very concerned to reducing the atmospheric carbon budget. On top of that, some of this carbon will come out as methane, even though we are currently not very well able to distinguish between how much CO2 and methane will come out of these soils. We are also not quite confident on how much of these soil losses are going to be replenished by increased carbon sequestration by plants, partly because there is a lot of disturbances forecast for Arctic vegetation, and it's very hard to quantify, therefore, how effective this process will be. So my last slide, thank you, yes. My last slide actually goes to summarizing this in terms of what that means for people and the action. Obviously, urgent, ambitious, and sustained emission reductions are needed in order to what is the word I'm searching for? I don't want to say stop, to limit the loss of cryosphere elements in the future, and actually enable a lot of the ecosystem-based adaptation options that we are seeing, and also open pathways to resilient development in the region. We have to strengthen multi-scale linkages of governance arrangements across sectors, jurisdictions, and short-term to long-term timeframes. We have to support effective responses through investing in capacity building in the regions, linking multiple forms of knowledge, including local and indigenous knowledge, with decision-making in cycles of adaptive governments. And we have to cautious and highly adaptively manage our resource management along trajectories of projected change, applying an ecosystem approach and preparing for surprises. Also, conservation is part of the story. We have to establish networks of protected areas to strengthen biodiversity resilience and ecosystem adaptation if we want to make a more effective adaptation to these changes possible. Thank you very much.
Thank you very much, Martin. We're now moving from the polar perspective to the small island perspective, and Elizabeth Holland is going to give us an interesting presentation. Professor Elizabeth Holland is the Norway Pacific Chain in Ocean and Climate Change and former director of the Pacific Center for Environment and Sustainable Development at the University of the South Pacific on Fiji. She's a lead author on Chapter 1 of the Special Report on the Ocean and Cryosphere in a Changing Climate. The floor is yours.
Thank you, and thank you to the authors who went before me and laid such a beautiful framework for what I'll present. The Pacific Islands called very strongly for a special report on 1.5, and that formed the foundation for what our approach was for the small island states. And the key findings of the special report on 1.5 can be summarized here. Every half a degree matters, every year matters, every action matters, and the time for action is now. So it's on this foundation that we pursued the special report on oceans and cryosphere and balanced the cryosphere, which you saw so beautifully presented, with the oceans and the small island states. As you heard in the previous speakers, sea level rise is accelerating and is one of our major challenges for the small island states of the Pacific. And you can see that we're already facing, this is a look at historical centennial extreme sea level events. And according to this area, the black dots are locations where these HCEs are already occurring annually. So our countries are shown here. They already have black dots. They have black dots in this scenario. They have black dots in this scenario. And the date line, which is the split for this projection, crosses through the middle, through our islands in Fiji. So some of Fiji is over here and some of Fiji is over there, and our university serves 12 Pacific countries, not just Fiji. We just happen to have our main campus located in Fiji. Where do I point this? All of these risks that I'm sure that you'll see in this slide before, warm water corals, kelp forests, seagrass meadows, epipelagic, rocky shores, salt marshes, estuaries, sandy beaches, mangrove forests, are all important to sustenance and life on our islands. So you can see that we're already at 1 degree in an area that's dangerous for us. Should we lose our warm water corals, we'll lose the protection on our islands and the coastal protection that we have. We took special efforts in the IPCC Special Report on Ocean and Cryosphere to address small island states. And we addressed it. You can see that it's dealt with here, and that in many cases we have very limited options to face ocean acidification, ocean warming, sea level rise, the ongoing cryosphere changes, and very importantly, extreme events. Like the Caribbean, in 2017 had a blockbuster hurricane year that was followed by this blockbuster hurricane year with Hurricane Dorian. In the Pacific, we've had Tropical Cyclone Evan, we've had Tropical Cyclone Gita, we've had Tropical Cyclone Winston, and we've had Tropical Cyclone Pam. Both Tropical Cyclone Pam and Tropical Cyclone Winston were record-setting for wind speeds, for intensity, and for their impacts on our islands. And you can see in this figure from the Summary for Policymakers, this is looking at what the non to moderate responses are and the maximum potential responses. And you can see that we're already beginning to be in a risky zone for our urban atolls, and that we're very quickly moving beyond the limits of adaptation for many of our capitals, like Tarawa in Kiribati and Majuro in the Marshall Islands. Very important to us in the Pacific is the weaving together of scientific, indigenous, and local knowledge. The relationship that the Pacific has with scientific knowledge is mixed. You may remember the many gifts that Captain Cook brought to us. They included smallpox, compromising our reproductive capacity. So following that, we had nuclear bombs tested in Bikini Atoll. So our relationship with scientific knowledge, while we stand with the science, and we are fighting for the science in the negotiation rooms, needs to be informed by local and indigenous knowledge. And it is this co-production of knowledge that gives us hope for the future, that gives us hope for us all to paddle in the same canoe. Because when we are paddling together, there is no greater magic. As your paddle hits the ocean at the same time that all of your other paddlers hit the ocean and you propel us together, the momentum for change is tremendous. And that's what we're calling for now. We're governing in a very complex landscape. We've got the contiguous zone, we've got the exclusive economic zone, but we have the open ocean that much of our fisheries are going in now because they don't want to pay the fees that we're charging. So you can see that for the first time in the special report on oceans and cryosphere, we're addressing some of the complexities of governance. We remain scientifically neutral, but not policy prescriptive. We're just highlighting the complexities and what the repercussions of those are, and they're critical for our ocean states. So for us in the Pacific, we can summarize the messages thus. Every island matters. We are already losing islands. Every island matters. Every centimeter of sea level rise matters. Every body matters. Because as Ko said in the video at the beginning of this, we need to be looking at the most vulnerable people, and we need to be addressing the needs of the vulnerable people. Every voice matters, because it is together that we can sing a chorus, a song that propels the momentum for change that we need. And the time for action is now.
Thank you very, very much, Beth, for this really alarming presentation. And this brings us to the last presentation in this event. Jean-Pierre Gattuso. Jean-Pierre is CNES Research Director at the, I have to train my French, sorry, Laboratoire d'Océanographique de Villefranche in France. He was already involved in AR5, and he is coordinating lead author of Chapter 1 of the Special Report on the Ocean and Cryosphere in a Changing Climate.
Thank you. So we are going to move into the solution space. It shows on this screen, but not on this one. She's trying, yeah. That's all right. Here it is, yeah. Maybe you just need to wait a while. full screen. Okay. Here we are. So we are moving into the solution space. And I will look at the solution space from an ocean perspective, not from the cryosphere perspective. And I will especially focus on material which is available in Chapter 1 and Chapter 5 of the report. It has been long recognized, and we heard the previous speakers telling us that the ocean is a victim of climate change. It is only recently that it has been highlighted that the ocean is also a space for solutions that can help mitigation as well as adaptation. And there is a tendency at this Blue COP to try to get the ocean more prominent in the negotiations and highlighting that it can help indeed. So in Chapter 1, we have this figure which tries to summarize most of the actions that can be taken from here, the ocean and also cryosphere perspective. And we looked at 3 groups of potential solutions or measures, measures that could address the causes of climate change. And that includes renewable energy, increasing energy efficiency, reducing atmospheric pollution. I'm not going to go through all of them. Some are nature-based, others are, strongly human-controlled. Then we have this top group supporting biological and ecological adaptation, which comprises pollution reduction, conservation, assisted evolution, and restoration and enhancement of ecosystems. And finally, on the right-hand side, enhancing societal adaptation with various measures that can be contemplated to assist adaptation of societies. And this covers, as you see in the bottom part in the legend, both mitigation in green and mitigation is in green and in orange. Mitigation in green means are measures that are reducing the sources of greenhouse gases, and the orange mitigation measures are those which are increasing the sinks of greenhouse gases. And this is exactly the terminology used by the UNFCCC, the definition of UNFCCC with respect to mitigation. And the blue dots are adaptation measures, which are mostly on the right-hand side and also at the top. And here on the side, the small numbers show the chapters which cover those measures. For example, restoring and increasing coastal vegetation is covered by Chapter 5. Some measures are not covered in the report. As you can see, for example, carbon capture and storage, bioenergy with carbon capture and storage are not covered because they will be covered by the AR6 Working Group 3 report, and perhaps also Working Group 2, I'm not quite sure. So that was not part of the assignments of SROCC. Finally, there is a group of potential measures which is missing from this graph, and this is solar radiation management. It's also not covered in SROCC. Some of those measures can be implemented in the ocean, but it's not covered here. It will be covered by the Working Group 3 report. So all those measures have the objective to reduce risk. I'm sure you have seen this before. It's taken from Chapter 1, the cross-chapter box on risks. So risk is at the junction of vulnerability, hazards, and exposure. And all those measures have the objective to reduce either hazards, vulnerability, or exposure in order to decrease the risk. For example, here hazards, decreasing hazards and moving to reduce the risk level. So, and this is the main figure I want to show you. It's out of chapter 5. It was led by Phil Williamson, who is not here, an LA of chapter 5. So this figure is quite busy, and I will show you, explain to you how to read it. So we have here the measures that chapter 5 looked at. Marine renewable energy, ocean fertilization, enhance weathering, restoring and conserving coastal vegetation, marine protected areas, reducing pollution, including nutrients, restoring hydrological regimes, eliminating overexploitation, assisted evolution and relocation and restoration from the perspective of reef systems. At the top, you have two sets of variables. On the left, the benefits. On the right, the constraints. And the benefits we looked at are, of each measure, is their capability to reduce the impacts of warming, acidification, sea level rise, and then those three combined in the fourth dot. And the last dot in the benefits are the co-benefits. You will see that some measures have a very low effectiveness to reduce the impacts of climate change, but they have so many co-benefits that they are really low regret measures that you want to actually implement with low regret. On the right-hand side, the set of dots indicate the constraints, starting with the trade-offs, technical issues to overcome, the cost for warming, and governability challenges. The legend here, at the bottom here, the shades of blue, the darker the blue, the larger the benefits, and at the bottom, the darker the red, the larger the constraints. And finally, the confidence level is indicated as IPCC language, using the thickness of the line surrounding the dots and rectangles from very low confidence to very high. I forgot to say that for some measures, there are two pictograms. The circles indicate the global implementation of those measures, for example, for enhanced weathering, that is alkalinization, or the local implementation of this. For example, you might want to provide alkaline material to very local bays to preserve a coral reef. That's an example. So, that being said, there is a lot of information in this figure. So let's look at three groups of measures. The first is really the decisive measures, which are very good in terms of benefits and have relatively limited constraints. For example, the marine renewable energy is a fossil fuel substitute, so it's really improving, helping to reduce warming, acidification, sea level rise. It has relatively little co-benefits, but that's not an issue. It's so effective to limit the key climate-related variables. And it has relatively few constraints, some trade-offs, but there are really not really technological issues to overcome. It's a well-known, at least for aeolian energy, well-known techniques. The cost is quite okay, and there is very little, well, there are some governability challenges because there is some pushback from people in some areas. The second group is what we later called low regret actions or measures. Those measures have a relatively limited efficiency to reduce warming, acidification, sea level rise. For example, marine protected areas have little to do with reducing warming or sea level rise. It could help for acidification if there is vegetated areas involved, raising pH. But those measures here have so many co-benefits, most of them here. For example, restoring a mangrove at the global scale, it's a very small contribution to mitigation, but it has so many benefits in terms of coastal protection, in terms of maintaining biodiversity, and also helping with fisheries. And finally, another set of measures have great effectiveness to reduce warming, acidification, and sea level rise, but there are so many constraints, such as trade-offs or technological issues to overcome, or they are costly and sometimes very difficult to govern. And these are ocean fertilization, enhanced weathering, and assisted evolution. So that's a panorama of what's in this chapter 5 in terms of ocean-based measures. So my own conclusions, I'm saying my own because we moved forward after the publication of this report, and I will tell you in a minute. So that's quite obvious. Climate change has already affected marine and coastal ecosystems and the services they provide. The Paris Agreement has the potential to avoid the unmanageable, but one must also manage the unavoidable. That is, as my predecessors have shown, there are changes that are inevitable, even if the objectives of the Paris Agreement are met. So there is a strong need for adaptation and implementing measures to complement mitigation. And the ocean provides opportunities for both mitigation and adaptation. And the conclusion I draw from this figure is that most global measures except renewable energy exhibit too many uncertainties to be recommended for large-scale deployment. Local measures are low-regret options with huge co-benefits. They can be scaled up immediately. We know how to do that. We know how to have a marine park. We know how to restore mangroves, for example. Although those measures are far less effective to address the global problem. And finally, the greatest benefit is, of course, to have a combination of those global and local measures. So we have moved forward, and this is kind of a publicity for tomorrow's presentations. We have this policy brief which has expanded. We are looking in many more measures than in the SROCC report, and we have clustered also those measures, and I will present this tomorrow. Thank you very much.
Thank you very much, Jean-Pierre, for this really interesting presentation. This was the last presentation for this event. We have now one more speaker, and I'm really happy she is here. This is Co Barrett. Co Barrett is the Deputy Assistant Administrator for Research at the National Oceanic and Atmospheric Administration, where she supervises daily operations and administration of NOAA's research enterprise. In 2015, Co was one of the first women elected to become a vice chair of the IPCC. For over 15 years, she has represented the United States on delegations charged with negotiations and adopting scientific assessments undertaken by the IPCC. So, Co, I'm really glad you're here. Co was an integral part of this report from the beginning. She didn't miss a single meeting, so thanks for being here, and I'm looking forward to your perspective.
Can I use your mic? Yep. So let me just start by saying it's a misnomer to say that I'm going to be providing the expert perspective, because you just heard the expert perspective from all of the authors who are working on this report. I was just fortunate to be the champion for the report, to watch the amazing work that they did over the course of 2 years, synthesizing and assessing the science to make that understandable for you. So, first thing. I want to share a little bit of inside baseball about the way that IPCC works, because for this report, it was particularly interesting. When we started this assessment cycle, we had 55 proposals for special reports that governments wanted us to undertake. So we were like, how are we going to, sort through 55 different proposals to agree on 2 or maybe 3? And the co-chairs from the working groups decided to kind of bundle them into 9 different bundles. And one of the bundles was ocean and cryosphere. But it was a bundle of a couple of different proposals. But lo and behold, when we were making these decisions with governments, they chose that bundle, ocean and cryosphere together. And I don't think any of us really recognized in those early days that that bundling was a fabulous opportunity for IPCC to tell a story about water as the lifeblood for this planet, wherever it exists. And if I can just share with you a key message that you might want to take on board as you communicate this report to others, it's about water as the lifeblood for this planet. Whether it exists in the frozen high mountains, in the polar regions, flowing down to coastal zones, contributing to sea level rise, and existing in the oceans, is about water. And it's a connected narrative that I think the authors have done a fabulous job of laying out for you. So that's kind of a key message I leave you with. And the only other thing I want to share before we go to questions, right? We have a section on questions. Is you saw me covered up in my red big bundle, a jacket, where I was in Alaska visiting this permafrost research tunnel, where they have just thousands of years of permafrost kind of layered, where people can just walk in, very bundled up, in order to see just exactly what permafrost looks like in its frozen state in the land. That tunnel has to be air conditioned in the summer in order to keep it viable. In the winter, they can open the doors. But in the summer, they are air conditioning that permafrost. So it was really fascinating to just see layers and layers, thousands of years of layers of permafrost there. But it also kind of illuminated the vulnerability. The reason I was in Alaska, though, is that I knew I would be asked to be one of the spokespeople for this report. And I knew we had pages and pages and pages of kind of dire impacts to share with the world, but I needed to go to a place in my country where I could talk with the communities that were already being affected by this. So I had the chance to visit with indigenous communities, to listen to them, to hear their concerns, and it sensitized me to the issues that people are already experiencing, especially in these indigenous communities that are so dependent on their way of life, their natural resources. And it ends up being a really strong message for me in this report that we have considered the perspectives, as Beth was saying, of indigenous people who are being so affected by these impacts. So I just leave you with that and hope we have a fruitful question and answer period. Thank you.
Thank you very, very much for this commentary, Rico. So I would like to ask all speakers to the podium. So now you can ask all the questions you would like to ask, but I suggest, as Jean-Pierre has to leave soon to another session, if you have any questions that are related to Jean-Pierre's presentation, that we maybe start with these questions.
Hello. Firstly, I'd like to thank you all for taking the time to really unfold a very important report. My name is Alia. I'm from the United Arab Emirates. The question that I have is for mitigation, and it's kind of combined between, well, I think most of you would be able to answer this question, but since it's mitigation. In terms of areas that have saltwater intrusion in islands or places that are close to the sea, is it wise to kind of try to maybe introduce estuarine fauna or flora into the inland? So, for example, maybe cultivate mangroves inland using the saltwater intrusion from the groundwater. Is that something that you would see as mitigation, maybe?
Well, anything that would store carbon will be a mitigation procedure. As we have reviewed the literature, we didn't come across any publication describing this, a technique that would enable to grow mangroves inland. But if I'm not familiar with the topic, but if it's a successful operation and if indeed carbon is stored in the process, it would qualify as a mitigation process. But again, we have not reviewed any scientific evidence for that.
Hi, I'm from Colombia and I work with tropical glaciers. We create a project of citizens and we are combining like science and doing a documentary in a book. As you know, the tropical glaciers are one of the most affected and really related to indigenous community. So for me, it's like how you could take this IPCC report and communicate it to the community and to make it able, because sometimes the struggle for us is trying to combine science and this perspective of the communities and the indigenous. Thank you.
Katja, can I take a first stab at that answer? So I think the IPCC reports are a tremendously valuable resource for people to use in communication with their communities. However, the most effective communicators are people who are working with the communities, who have a trusted relationship with people there, far more effective than, say, a scientist from outside could ever convey. And I think it would be hard to underestimate how important it is to use local people who have relationships to share the information. And also, IPCC is somewhat limited in the way that we can tailor information for specific localities. We do global assessments, but that doesn't mean there isn't a need for that. We need, boundary organizations to kind of take the information and bring it home to the people.
Yeah, Martin, please add.
Yeah, I think that relates also to something we have found out in the polar regions chapter, but which is actually true across the board. And you saw it in my last slide. As we have to start responding, and as if adaptation is a critical part of that response, it is actually most efficient not to communicate. It links on to what Kobat said, but basically engage in policy processes or engage people into policy processes, and in these policy processes actually bring the indigenous knowledge of these communities and the science that we have combined, for example, in SROCC together to then seek solutions and learn together over doing these solutions. So it's a learning process. We are basically all, at the rate of change, we are seeing tasked to making it up as we go along, and the science clearly says that that is the most efficient approach to this.
Yes, and that's reinforced by our efforts in the Pacific. It's very important to distill the essence of what some of this complexity represents into bite-sized pieces, but it's also important to translate it into the local languages. So I'm speaking from one of the richest language regions in the world, and it's extremely important to make that translation. For example, in Fijian, we don't have a word for long-term climate change. So we had to reconstruct the language to be able to describe what climate change is. And as Martin said, and as Ko says, it's part of a learning process. And we as scientists can learn a great deal from that process and from listening to the voices of the indigenous and local people, because it gives our science much greater context.
Yeah, first the sir in the first row, and then these two. Three.
Thank you, moderator. I have a question to Martin. On your final slide, you wrote strengthening multi-scale linkage of governance arrangement. Do you have any suggestion as how to strengthen multi-scale linkage of governance?
Yes, talk about. From the very perspective of the polar regions, coming from there for a moment, both polar regions have considerable international cooperation for governance. So very often there is both formal but also informal governance that relates to these two systems, more informal in the north, more formal in the south. And it is about actually connecting these governance systems and the benefits they can provide for sustainable, resilient pathways to across the other government scales. In the Arctic, that's, for example, the national scale, but also the sub-regional scale, and importantly then, linking on to the last question, also the local scale. And so this makes for a more effective, more adaptive governance where we can have deliberations at certain levels and policy processes at others. So there's a lot about these kind of vertical connections. There's also horizontal connections, as you need to, for a more integrated and more adaptive response, you need to connect across sectors, across topics, not only economic sectors, but also across conservation, management, etc. So there is that level as well. In the Antarctic, there is a lot of topical the system is weary in terms of being slow because it has to be consensus driven. And so it is more or less finding ways to actually find to influence that system, or how the system can influence itself, that it can be more readily, more fast responding.
I'm sorry, the question was addressed to Martin, but I think there are a number of illustrations that can come from the Pacific as well. We have a long tradition of local management of our oceans with small marine protected areas. There are over 1,000 of those marine protected areas within the EEZ of Fiji alone. And it is from that relationship with the ocean that our Pacific delegations are now calling for integration of the ocean and the climate nexus. And I think this report provides a very strong foundation for that. And we also have regional governance arrangements, for example, on fisheries. And reinforcing the top-down and the bottom-up is very important, because that's the most powerful model for change.
There was, yeah, the lady over there.
Yeah, thank you very much for giving me the opportunity to ask a question. First one to you. I would really like to know, you talked about the algae growing underneath the ice, the sea ice. Could you anyhow quantify what kind of value this has for the global oxygen production and the global, it's obvious for the local food web. It's a basis of the food in the Arctic and in the polar regions. So if this ice is gone, or if its extent shrinks, and if it's not longer available for a longer period in the year, so this means a cut down of food, of krill, of it's the basis of the food web. So do you have any ideas how this affects the local, the regional food web, and the interactions with the whole marine ecosystem, and how this loss of algae puts at risk our global oxygen production, our global food web, and the ocean web of life in general. So do we have any numbers when we talk about numbers? This is my first question. So I have another one. Sorry. To Elizabeth, you raised this point in your file that every half a degree of warming matters. One thing that struck me when this 1.5 came up, and which figure that was included in the SROCC report, is the coral reefs. So it's not only half a degree that matters, it's every bit of warming that matters. And 1.5, this goal that has been set in the Paris Agreement, which seemed to be so ambitious, isn't even not ambitious enough, because we lose the coral reefs and we lose 500 million people who depend on it, and we don't know what really this means for the life on Earth, because for the ocean ecosystem. So mustn't we shift our discourse, our priorities? Mustn't we talk about, when we talk about we must not leave no one behind, extend this to the marine species, to the corals? And so we are in a, when I came here, I thought we are in an ocean climate biodiversity crisis. But the valuable, the wonderful, the tremendous work you have been done, this is really much appreciated, but they do not listen over there. So we are in a, not in an ocean climate biodiversity crisis, we are in a governance crisis. We are in a political crisis. The political will is lacking. So mustn't we stop talking about numbers, but talk about the ways decisions are taken? And why don't they listen to you, to us? And we are facing not only an environmental crisis, we are facing a humanitarian crisis and a crisis of civilization. What is the future we leave behind, not only the our environmental heritage to future generations, but also our humanitarian heritage? What do they face when we do not tackle this crisis? So what is the discourse we want to push here? Thank you.
So you raised a lot of points, and I acknowledge these points, I think, because they're all valid concerns. We here speak for IPCC, so this is about science and what it contributes. We assess published science. So I have to kind of circumnavigate your last question, because that is not a discourse that we have as scientists here in IPCC, while we are probably at least sympathetic to these objectives that you bring forward. That's not what IPCC does. We assess science and bring it to policymakers. Then I take a hit at your first question, even though that is basically a question that we could talk for hours about, because it affects the entire polar marine system. But in a nutshell, you have to think about it slightly differently. We do have numbers, but you don't have to see it as a threshold, as a tipping point. It's not that the ice is gone and then we don't have any production anymore. We also have ice forecast to be there seasonally. So it's a lot, and the productivity happens a lot of that at the ice edge, being at a place where we have productivity possibility during the time of highest irradiance in summer. So you have to think about that we still have this marginal sea ice zone forecast until the ice may be gone if we heat this planet too much. But we have seasonal sea ice systems in both Antarctica and the Arctic for the foreseeable future. So some of this productivity that is associated to ice edge will be there, as will be the species. So the species will have more limited habitat. That is what we see coming. But the productivity numbers, actually, for example, that are associated to the marginal sea ice zone have gone up in the last couple of years, just because there are other conditions that contribute to that productivity that were more favorable in the Arctic Ocean. So in a nutshell, that is, you have to look at it more differentiated. There are limited extinctions forecast in terms of species, in terms of ecosystems. One ecosystem that we have almost lost is multi-year sea ice in the Arctic, but we don't quite understand what that means for productivity. So that might be just a short overview of answering your question.
And to just reinforce the point that Martin made on the role of science, we have to remain credible as scientists, and it's our job to talk about numbers. If I were to talk about 5 meters of sea level rise in tears, would that increase the credibility of the message that I deliver, or would it decrease the credibility of the message that I deliver? So it's really important for us to recognize what our role is, because as everybody in a canoe has a different role. If, as a pacer, I was trying to steer the boat would go in circles. So it's our role as scientists to ensure that we have the numbers, we've built the foundation. And it's our role as well to share this information with each of you so that you can help us translate it into the human experience and into human actions. And it's together that we can make that difference.
The next one was the lady with the red pullover here.
Hello, everyone. Thank you for the comments. And well, my question was a little bit related to what the lady was saying, and it was related for the men that left, but maybe some of us you can answer. It was regarding the concept of governability, and if you could develop this concept and how this is a constraint for the measures to be implemented.
So are you asking about, for example, the governance slide that I showed and the complexity of that governance slide?
Okay, it was in the Jean-Pierre presentation, in the last slide, where the dots were there, and it was about the constraints and the, yeah.
You're asking about the constraints of governance, of improving governance?
Yeah, if you could develop this concept on how it's affecting the measures.
Okay, so I try and answer. I hope that, or somebody else. So you can come up with more effective governance to respond to climate change. We had through various ways. I listed a few of them, and they are valid for the polar regions, but in part of them are also valid elsewhere. And they need to be empowered almost, that you need to, there is a lot of enabling conditions for such better governance. We talked about how we need to connect across scales. We talked about how we have to connect and co-produce local and indigenous knowledge and make it become part of the decision-making process. So in order to enable that, a couple of key things that are enabling that is we have to actually, in order to have for let people participate and different knowledge sets participate, we have to transform quite a number of our renewable resource management, so natural resource management institutions. They don't currently allow for that, so that's an enabling that we need to do. How can we do it so that we can assure that participation decision making is done? But that has a red tail of things to it. It needs to be actually paralleled with not only the changing the institutions, but it also needs to be empowered by knowledge. It needs to have the capacity enabled for people to participate in such decision-making processes. Many people in Arctic communities that are the ones that have knowledge are now almost exclusively bound up in decision-making processes and say they cannot spend the time on the land enough to secure their own livelihoods. So there is a lot of capacitation. There's also knowledge building. There's education that enables such participation. There are many other things, but I leave it at that for that. And I hope that was for benefiting.
in addition to what Martin has just said, intergenerational transfer of those ways of knowing is critical because, like the Arctic, the Pacific is spending a lot of time developing frameworks, developing governance strategies, and much of their time is compromised from actually being at the sea or doing their other jobs.
And maybe, sorry, just adding one, because it's important. One thing that we have found out is that, especially when it comes to ocean and cryosphere, lots of the changes are immediate but have a long-term perspective. Many of our governance institutions are not able to justify that long-term perspective. So also here we have to find ways to make decisions that are informed by long-term projections and not only short-term risk avoidance. I think that's a crucial thing, and I wanted to mention it. Thank you.
Thank you. My name is Karin Zaunberger from the European Union. First of all, thank you very much for these presentations and for the report. My intervention is actually more a comment than a question to the low regret options. I would just like to draw the attention on the work of the Convention of Biological Diversity, actually the sister convention of the UNFCCC. And there's actually a number of decisions that are highly relevant in this context. Notably, there were priority actions for coral reefs. There were at the last COP, there were the adoption of a voluntary guidance on the design and the effective implementation of ecosystem-based approaches to climate change adaptation and disaster risk reduction. I still see too many unfamiliar faces here, and I really hope that in the turn of next year, there will be a lot of convergence of the Rio conventions, all three of them. And as the term ambition, nature, and people is really should become the leitmotif. Sorry, it's more common than a question, but thanks a lot for the report. Thank you.
Thanks a lot for this comment. Thank you. Yeah, there's a question.
Hi, thank you. I come from Latin America, and I am a student of philosophy and anthropology. And I was concerned about what Ms. Ko said about the narratives. So, and you, I don't remember your name, but you talk about indigenous knowledge and how to include or how to dialogue with indigenous knowledge. And I was talking about the narratives because I don't see any indigenous or other narrative than Western science in the IPCC informs. So I was wondering if there's something you are doing to create a dialogue or something like that between indigenous knowledge and science knowledge.
Like all processes of change, it's a process and it's a journey. I first called for inclusion of indigenous knowledge in the IPCC in 2007. It's now 2019. So it's taken us a long time to get here. And again, it's how we keep in dialogue and how we keep developing the stories together. The words that we use were carefully chosen. It's co-production of knowledge. It's not elevating one way of knowing to give it more power than the other way of knowing. But as you've just observed, the way science can be structured can make it difficult to balance it out. And so I think it's a learning process. And please join us in that learning process and in finding those solutions, because many times our best inspiration comes from the next generation, not those of us who are stuck in our own ways of knowing.
Yes, super, thank you. And you have two people here who worked very hard to actually elevate this way of thinking about the co-production of knowledge in IPCC. I just add to what Elizabeth said, that there is actually a box in chapter 1 that I recommend you to read that portrays that and is hard worked and hard fought. And the other constraint that IPCC has for very good reasons, but that would enable such a, or that would have to be reviewed in light of this co-production of knowledge, is actually that we are only assessing peer-reviewed knowledge, peer-reviewed scientific papers.
Yeah, there's one more question.
Yeah, thank you very much for your very, very important presentation. And I have a question about this report. The output is how the policymakers accepted these reports. Actually, when I read the, I'm Kainuma from Japan. I'm involved in 1.5 report, but I'm not a specialist of ocean. But after this ocean cryosphere report was published, I was really scared. I did not so much not about the ocean, what is happening. How this report will be accepted to, in this COP25, and policymakers, this report, I think, pushes the policymakers to increase the ambition, but I want to know your thoughts about this.
Those discussions are going on right now in the Research and Systematic Observations section of the UNFCCC. The text is being drafted to reflect. There are many different positions on this. The position of the small island states is that we welcome the report and we note our grave concern. It is not clear that that text will be what is evolved. So please work with your delegations to make sure that this science is translated, that this science informs all of the policy negotiations. Some of the governments are not welcoming our report. I think the information may be a little scary for some.
So there's one more question, and after that, I think we have to come to an end.
Sure, yeah, no problem. It was more a comment than a question, like my colleague said. So basically, well, I'm Joan, I'm from Spain. I have a business background. And sometimes we think that, well, just here, people, I don't know about your backgrounds, but my colleagues said, oh, why do you listen to the IPCC? Or what do you know so much about science? I said, oh, we should listen to the science, as I'm doing. I'm coming here every day. I'm reading the reports. I trust the IPCC more than anything else in terms of climate change and science. So I just wanted to thank you so very much for your efforts, because what you do matters. It matters a lot, especially in the private sector, in the government sector, in all the sectors. This should be multidisciplinary and take a holistic approach to tackle sustainability and especially climate change, right? So basically that, again, thank you so much. It's unbelievable I'm here listening to you, to your words, to your hard work that you've been doing, and I appreciate it so much, and thank you, and this is going to be translated in the private sector as well. Thank you.
And I think this was the best closing remark we could have for this session. Thank you very much for that comment. I would like to thank all of you for your interest and for coming to this event. I would really like to thank all the speakers. Two had to leave, unfortunately, already. I would like to thank all of you for your time and your efforts and for giving us deeper insight in the report. And I would like to point your attention to the two other sessions on the special report we are going to have in the afternoon, one at 1 o'clock on risks to ecosystems and human systems, and one at 2:45 on the future of sea level rise and potential response options. So if you are interested, you're more than welcome to join also these sessions. Thank you very much.
And as an author, I would like to just take a moment and thank the tremendous efforts of the IPCC Secretariat to make this possible and our IPCC leadership. We often forget to do that.